And I don't know how this led to, but then I joked to Bhavani just to ask her that, is it that only women can participate in the cloud native in women in cloud native group? And then she was like, no, that's not how it is. So glad to be here because I know I've been talking about this group to a lot of people. I'm sure, a few of them must have reached out to Nancy or Bhavani or Sankita as well. So, I'm really liking the work that's happening, and I'm pretty happy to be here. In terms of work, I mean, yeah. So I'm Atulpriya Sharma. You can call me Atul, and on Twitter I go by the handle the Tech Maharaj. I currently work as a senior developer advocate at Infra Cloud Technologies, and we are based out of Pune. So as a company, we are into open source product development, consulting, as well as services offerings. And as my role as a developer advocate over there, I work with different clients from different domains. And the focus is there to help them and their clients and their users adopt, open source technologies and platforms as well. So, I do a lot of work around cloud native Kubernetes and DevOps in general. And observability and service mesh are a few areas that I focused on during the few months that I spent time on. And personally, since I've spent some time around service mesh and observability, these are some areas that I feel, I might not be a pro, but then this is where I feel I enjoy it, especially in the observability space. So when Bhavani reached out, I was like, okay, this is something that I like doing, and probably I can help folks just get started with observability and see how things are in that world. Apart from that, I am also a CNCF ambassador, OSS contributor, and a maintainer. So I am the organizer for CNCF Hyderabad. Apart from that, I am the maintainer for an open source project called Parallels, which is a Kubernetes access management tool, which provides you zero trust access for any clusters that you have. That's pretty much on the work side of things. Outside of work, I am a food and travel blogger. So when I'm not working, you can find me at a restaurant or on a road trip somewhere. In fact, I just came home a while ago, maybe half an hour back. I'm home. I was out the entire weekend. So that's what I do in terms of work and non-work related items. Uh, we'll quickly get into the agenda. I think I've kept it straightforward. I've kept it short and simple. A quick introduction around the whole observability space, the history of observability and how it came into being. Personally, I'm a big fan of history, whether you talk about monuments or architectural marvels, or you talk about science and engineering. I always feel that it's very important for us to understand the history of things, how things shaped up and what they are today. So it helps us understand it better of, why it probably started in the first place and how it has taken shape today. Then I'll talk about observability as such in software development. So, why it's required, what are the various aspects, components, pillars of observability. Quickly touch upon some tools. And I'll have a simple demo as well, where I would be touching upon custom metrics using Prometheus and doing some visualization using Grafana as well. And then we could have time for some Q&A as well. In case we don't, I'm hyperactive on social media, so you can reach out to me if you have any questions, and I'll try to answer you then. So I think to start with, like I said, outside of work, I am a travel blogger and I just came back from a road trip. And I'm sure a lot of us enjoy going on road trips or, just taking, travel seriously and just getting off work to relax. And I think this is a question I had asked earlier as well to a lot of folks that what are the few things that you do before going on a road trip? So if anyone has anything, you can put it in the chat or you can unmute and probably answer that. Let's say, you have to go on a road trip tomorrow. What are the things that you probably uh, do before going on a road trip? I know Nancy goes on a lot of road trips,
Yeah,
so she
yeah.
might have some answers.
So, yeah, your question is like, what are the things when going on the road trip, right?
Yes, what do you do before going on a road trip? Like you're going on a road trip tomorrow. What are the things you do before that?
I ensure that everything is working, like my car. That would be the first step, ensuring that everything is working well. Like all the tires have the, like proper gas, and I have full petrol, and all these are the few things which I'm going to check basically before. Is it a right answer? What about others? What do you ensure before going?
Yes, I think Sindhura says planning. Yes, absolutely. Planning is a very large term, I would say, and it involves a lot of things in that. Checking your vehicle is definitely one major aspect of it. Obviously, you need to plan your route, you need to plan your stops, you need to plan food, and a lot of things related to that as well. So, especially talking about what Nancy said when it comes to vehicle, and it's a very critical thing. So before you go on a road trip, you need to check whether you have the required amount of fuel in it, whether your oil levels are correct, whether your brakes are working fine, whether air levels are fine, and things like that. Now, why I'm talking about this is that how are you able to check these things? Because let's say when you are talking about air pressure, you need a way to check the air pressure. You want to check what the fuel level is. You need a way to check what the fuel level is, and that essentially what I feel is observability in real life. Before even going to software systems, this is where this is one of the touch points of observability in our day-to-day lives. And what you see on your dashboard, the fuel gauge, which tells you a number. So it's basically a number which indicates how much fuel I have, and based on the number that I get, I plan and take decisions. So let's say if it is nearing to end, that is what it has given, and based on that, I go ahead and take some action. If my air pressure is low, I get a number that okay, it's less than 36 psi. I'll probably go and get air refilled as well. So that is what essentially monitoring and observability is. So that so basically there are systems in place which basically collect these metrics. They give it to you. They visualize it for you so that you can take some actions based on these numbers. And that is what is observability in real life. And we take that exact thing and put it in software systems as well. So going back in time a little, I would like to touch upon control theory. I don't know how many of you all know about control theory, but that's a branch of physics which basically deals with how control systems work. So again, as a very layman term that I've mentioned, we spoke about the car, we spoke about the various monitoring and observability aspects of a car. That's basically an example of control theory in practical life. So let's say you have cruise controls in most of the cars nowadays. So what essentially happens in that is you set a number that okay, I want the cruise control to be set at 80 kilometers per hour, and your controller will actually be constantly checking that number and checking with your current speed and the speed that you have set. And based on that, the actions will be taken internally within the system. So what we are essentially doing while designing a cruise control system is that we see the input from the driver, we see the controller, which basically takes the difference between the set number and the current speed as well. And then we have an actuator which basically ensures that that gap is matched. So let's say if your current speed is 70, you have set cruise control to 80, it will just increase the speed to 80 and it will stop. So these are the different components when it comes to understand how control system works. And that is something which is applied everywhere in real life. Car is one example. Because I enjoy travel, I can relate to it better. I'm sure if you do a lot of other things, let's say even if you cook, you probably would be able to relate to that as well. Let's say you are into baking, so you need to know what are the right amount of ingredients that you need, the right amount of temperature, the time that you need, and then you will decide how the entire thing pans out and the item you get later. And so that's pretty much what control theory is, and that is essentially translated into observable modern day observability and monitoring in software systems as well. So observability is basically the understanding how much information we have about the system that we are trying to control. So in case of a cruise control, it was the speed. In case of cooking, it's let's say the temperature and the duration that you have. So these are basically the metrics that we'll get, and we will take these as references, and based on this we are trying to control the system that is in question. So when this taking this entire example and putting it into a software system, it's quite similar. So what you see on the screen is a typical e-commerce application. It's a very high level design, and you see that a typical software system of this scale deals with, or rather interacts with, a lot of third party systems and has a lot of modules internally as well. So if you see here, there are different agents from where a user can interact. So it can be a web app, it can be a mobile application. Your app front end can be in some language, or it will be coded in something. So here, for example, in this image is Node.js, and then these can be hosted on EC2 instances, which can be put into some regions, put into zones. You can use S3 as your storage buckets, where the objects are stored, your images or videos or whatever you need for your e-commerce website. And eventually you need a backend as well for storing data. So it can be a Redis, it can be NoSQL, it can be MySQL, so on and so forth. And then most of the modern day systems interact with a lot of third party systems to get a lot of work done. So for example, let's say you're having a payment gateway, it can integrate with Stripe, which is again a third party system. It can connect with a Razorpay. You can have Google Analytics in place, which helps you understand your current website traffic, from where the traffic is coming, how's the performance. You can also connect it with a system like Zendesk, which basically is like, it provides you customer support and chatbot and things like that. So when you have such a large system in place, it's very critical to understand that there are so many points of failures involved in this entire system, because you're dealing with so many things. Uh, you need to understand what is happening at a particular place at what point in time, because until unless you have the visibility in the system, it's very difficult to manage and monitor that system for any eventuality. Even if something goes wrong, you need to know what has gone wrong and where it has gone wrong. And that is where observability comes into the picture. So all these points, or all these touch points, which is there in this particular diagram, we can have some sort of an observability tool present at each of these touch points. And it basically depends on the kind of data that is generated. It depends on the kind of functionality that particular tool, that particular module does. And completely based on that, you configure your tool, which basically gives you the data, the logs, and whatever is required for you to understand how your system is behaving, and probably take some informed decision based on what the information you get from such systems. So, observability, like I said, is the ability to gain real-time insights into the behavior and performance of complex systems through collection, analysis, and visualization of data. So these three are important because, first thing is you need to collect the various data that is present in at different touch points. So, going back to the previous image, what you saw here, the different modules. So you need to have some components installed on each of these modules, which basically help you collect the information from those points. And once you have the information collected, then you need to perform analysis on it. And analysis can be, uh, the analysis can vary based on the use case, based on the industry. It isn't based on your requirement. And accordingly, you can visualize that data so that it becomes easier for anyone to understand it better. Because what usually happens is such systems will generate huge amounts of data, which can be numbers, which can be just plain text, which can be some formatted text sort of, and it becomes really difficult for humans to go through that. So when you have a data in place, you analyze it. You might have some rules or checks in place which you apply, and just analyze the data that you have got. And then it's really important to visualize that, and in some way. And by visualization, I don't mean it has to be always a dashboard or a very good looking metrics and charts and stuff, but even presenting it in a simple way that anyone can understand, or at least your team can understand, that will become very easy for them to take any action possible, or any action that is required. So, uh, talking about observability, there are three major components or pillars of observability that you might come across, and these are basically metrics, logs, and traces. Uh, so metrics are basically the quantitative system performance, which is there in your software system. So quantitative, when we talk about quantitative, these are things that you can measure. So if, for example, it can be CPU usage, your memory utilization, your request latency in case of API calls and things like that. So these are basically numbers that you can collect, and you can take decisions on that. So these are absolutely quantitative in nature. The second pillar are traces. So usually when you see today, or even the e-commerce application that we saw, there are a lot of systems which are involved. So what happens generally is when you send a request, more often than not, it goes through a lot of multiple systems. For instance, let's say you are logging in into an e-commerce website. So a lot of e-commerce websites today allow you to log in with a different account, SSO, if all of you are aware of single sign-on. So let's say you have a Google account, you can use that Google account to, let's say, log into a Flipkart or an Amazon. Currently, that's not possible, but I hope you just understand, get the idea of that example. So, you can use different services to log in. So what essentially happens is that when you log in, you will probably key in, what do you call, you'll probably click that Google button to log in, and which takes you to Google where you enter your credential, it validates, and then the request comes back. So in this entire thing, what happens is your process has gone through multiple systems internally within your own system before it goes to Google's servers where the request is, where the credentials are verified and it is authenticated. And once it comes back, also, there might be things like permissions. Let's say if I'm an admin, I can see the store, or if I'm a user, I should not have access to stores. So these are the checks which are internally done within your system. So what traces do is basically they give you a graphical representation of how your request has moved from one module to other module or one component to other component. And as a developer or as a product manager, you can decide the level of granularity that you need. So if you want a trace to be present in every function call that happens, you can do that. Obviously, it will have a lot of data that will be generated, but then it will give you a very high degree of visibility. So I mean, whether you talk about metrics, traces, or logs, that decision of how many touch points you need, how much data that needs to be generated, or how much granularity you need, that basically is a trade-off decision that is taken based on the application that is built. So traces, coming back, traces is basically a request flow from one system to other. I have a very basic example image of traces in the next slide. And third one are logs, and I'm sure all of us would have used logs in some form or the other in our application. It can be a simple printf statement or simple print, or it can be console statement, your warnings, information, debug logs, and these are basically written by developers within the code where you can get information in terms of how your application is behaving, what are the parameters that have come in, how it has processed. So just to understand the flow of how things are happening, you add log entries to your application. Now, what you see here is basically example of metrics, logs, and traces. So the first image that you see is metrics is basically number that I discussed. So it's a quantitative metric. So for example, let's say you want to talk about API response time. So if that is a matrix which is collected from a particular module between 5:30 a.m. to 8 a.m., what you see on the screen is the graph here. And this can be from different systems, different requests that are coming in, or based on how you configure. But these are basically numbers and metrics which are just plotted on a graph. So it basically visualizes, and based on these numbers, you can take some decisions. Uh, the second one, what you see here are logs. So logs, like I said, all of us have used logs in some form or the other in the applications that we have built. So essentially, it might contain a timestamp as to when a particular event happened, and then some details about that particular event that has happened. So here, log level is information. You might have a message which says that, okay, there was no data that was returned, and then you can have any other thing that is relevant for your particular application. So your logs would look something like this. And then when you talk about traces, this is how your traces actually look. So when I talk about that request going from one system to the other system, or one function to the other function, this is how you see here. So this basically screenshot is from a tool called Jaeger. Jaeger is a popular open source distributed tracing tool. And what it does is that, once you install it in your environment, you configure Jaeger on the code base or the modules or the components that you need the traces for. And once that is configured, what it does is it will generate a graph like this. So on the left, what you see is service and operations. What you see here is that a request entered, let's say, a module called order services. And then within that, all the function calls that it has made. And from there, what are the other touch points or the modules the request has gone to? And this is what it shows the traces to me in a graphical format. So if you see, it starts with 0 microseconds and then it goes up to 560 microseconds. That's when your entire request has completed. And within, you can see that at which function, how much time a particular request has sent. So Traces are extremely critical to understand how your particular function might be performing, and to understand if it is taking some time. So, if there is some intensive data task or computation task that is happening within a function, you can easily point out from here that, okay, this is where something is happening. Or let's say from a user feedback, you received on your application, which says that, hey, your app is extremely slow and it takes a lot of time. So a user will be giving you such feedback on your platform, on your app store, or rating or review. This basically comes to your product manager or a product lead who would be like, hey, okay, the user says that it takes a lot of time for a particular action to complete. And then it would be the task of the developers to figure out what is going on, or why that particular request is taking time, or why that particular module is slow. So that's where all these three things will come very handy. So metrics would be like, actual response time from your server, maybe payload what has gone in, if there's a lot of extra data that is sent, which is not required, or things like that. Logs are obviously what you have written, so you know exactly how the flow is happening within your system. And traces will help you identify that if there is a particular function that is taking a lot of time, because of which the error is happening, the timeouts are happening. That's why traces will help you identify that, okay, hey, out of this entire module, this particular function is what is taking the most time. So now what you have found is that earlier your application was this huge and you had no idea where the issue was. But with the help of metrics, logs, and traces, you identify that, okay, this is a particular module which is causing problem. And now that you have identified that particular part, what happens is your entire focus will be on that small module. So your time to debug an issue, time to find the root cause of why that error is happening, or the timing is being reduced, that becomes really short. And that is why having any level of observability within your application is very critical. So just extending from there, talking about role of observability, and I think if you Google this, there are a lot of reasons why observability needs to be there in any software system. Whether you are just starting out with a very small application or whether you are building an enterprise grade application, I think some form of observability is added by all of us. So, like I said, it helps in enhance troubleshooting, because you get real-time insights within your system behavior, how your system is performing, when the request is coming in, which system responded, how much time it took, what other modules it touched upon. So these are the real-time insights that you have. And again, this can depend on a lot of other factors based on what your application is, what your domain is, what is the critical factor for your particular organization. Based on that, you can define what the critical insights for you are. So let's say if you're a banking application, you use UPI for transactions. So for you, response time is very critical, because the moment I give a UPI ID and if I say pay, you need, as a user, you need to get a confirmation whether amount has deducted and been transferred or not. So if that goes, let's say, beyond a few hundred microseconds or 200 microseconds, then for a user, it might be confusing that, hey, what's happening, whether it's working or not. So for a banking application, that's a very critical metric to track, for an example. Uh, Second, apart from troubleshooting, it helps you a lot with proactive monitoring as well. So when you have these any piece of observability implemented, what it does is that, because a lot of data and metrics you already have, you will know that, okay, this is a particular function or module which is being stressed upon, because a lot of request comes in, or a lot of particular type of requests are coming into that particular module. And that is why, it might have in future, it might become a bottleneck. So if required, you can, let's say, if you have a lot of microservices, and if you identify that, okay, this is a microservice where a lot of requests are coming in, and there have been instances where a lot of timeout have happened, or the latencies have increased. So based on this data that you have, you can come to a decision that, that, hey, okay, this is a microservice that is causing problem, or has caused problems inconsistently in the past. What we can do is, we can probably scale out that particular service, so that in future, if any of such things happen, it will already be taken care of. So because you have some data with you already, you are taking some proactive steps to ensure that, things of that sort doesn't happen. So observability is a very great tool to help you do some proactive monitoring as well. Thirdly, it helps you with faster incident response. So the example I gave you in the previous slide about a customer leaving a feedback that the application is slow. So instead of you going through the entire application, when you have all these things implemented at the right places, what it does basically is, it boils down to the entire module, or even a particular function, which might have caused this issue. So what happens is that, your mean time to response, MTTR, becomes very low. It reduces by a huge margin because you are not spending time in identifying where the issue has occurred because of the observability mechanisms that you have in place. So it basically gives you a very pinpointed approach of, hey, this is where the issue is, and this might be what is causing the issue. So your incident response becomes really fast. Lastly, pre-last, the fourth point is, improve system performance. So what happens in this case is because you are continuously monitoring your system with a lot of metrics, what you can do is you can optimize your system performance because you have trends in place, you have data, and based on those data, you can take good insights, data-driven insights, which can help improve your system performance as well. So if you are seeing a lot of, let's say read write IOs are increasing, your IOPS are, is increasing, that probably your storage is becoming a bottleneck. So in that case, if required, you can add more storage, or you can, probably optimize your code in a better way that your storage devices or storage services are, dealt with in a particular manner so that, your overall performance is improved. And lastly, it helps with root cause analysis, because of, again, the data that is generated. It allows you to perform real-time, very deep analysis of system to identify the actual root cause of what has happened. So this is why I feel, or rather, generally also why observability is added into the software that you build. And talking about how you can do this or what are the tools that help you collect this data. So there's always a term that is used in software engineering which is called as reinventing the wheel. So what you can do is you can either sit and design a system that will collect all these numbers from the various modules that you have, collected, analyze it, and represented it in a particular dashboard or a UI. So you can either create that thing from scratch, or you can make use of a lot of available tools in the market for getting the same work done. So as I say, why reinvent the wheel until unless your use case is very specific and none of the shelf available tools are able to cater to your needs. So what I'll be discussing now would be the open source tools, which are in the open source space, which help you with observability. And these tools are categorized into monitoring, logging, tracing that we discussed, which are the pillars of observability. So what you see on your screen right now is the CNCF observability landscape. So CNCF landscape in general, if you don't know, is a landscape of projects which is published by the Cloud Native Computing Foundation. And the whole idea of the CNCF landscape is to give you as a user a very high level view of the projects that are present within the CNCF landscape. So CNCF promotes everything related to cloud native. And when you build applications on cloud native, there are a lot of different activities involved. So, it can be things like infrastructure provisioning. It can be things like container orchestrations or container management or, observability as well. So what CNCF has done is they have created a landscape, and in that landscape, you can see a lot of projects that are part of it. Some of these are, a lot of these, or rather, most of these are open source. Some of these are built completely by the community. Some of these are built by the other organizations. So what you see here is the CNCF landscape for monitoring, logging, and tracing. And this was taken maybe a month back. The screenshot what you see here. So this might have been updated. So the CNCF landscape is something which is continuously updated. And based on my last update, there were about 1,200, more than 1,200 projects within the CNCF landscape, which are there, which are put into the different areas that we have. So what you see here are just three of them, which is monitoring, logging, and tracing. So if you want to know more about the CNCF landscape, all you can do is just Google CNCF landscape or go to landscape.cncf.io to get a whole list of the various projects that are present in the CNCF landscape. So monitoring are basically tools that help you collect, aggregate, and analyze logs and metrics. So these helps you to collect logs from different logs and metrics from different modules or the systems. So on the left, what you see are the popular open source tools. So you have Prometheus, you have Cortex, you have OpenMetrics, Thanos. And if you're already working in the cloud native space, I am sure you would have heard these names. And there might be instances where you would have actually used this tools in some way or the other as well. Again, and then talking about logging, these are the tools that collect logs messages. So What you do in this case is that there are tools which are present to collect the log messages that you have. So as a developer, when you're adding any logging within your application, these are the tools that help you collect the logs and process them, analyze them, and they take actions on them. So here, if you see Fluentd is one of the projects, LogIQ, Logstash, Splunk, Sumo Logic. So these are some tools which are quite popular when it comes to logging. And within tracing, there are tools that allow you to trace path of request, like I discussed in the earlier section. So within tracing, you have tools like Jaeger, OpenTelemetry, you have Elastic as well. And these are the tools which basically help you trace the request, how it goes from one module to other. So instead of you reinventing the wheel and building something from scratch, you can pick any of these solutions, just implement it within your system, and these tools can help you take care of what all your requirement can be. So this is again just a list of the various tools, open source observability tools. So when you have Prometheus, which is a monitoring system, you have a tool called Grafana Loki, which is Prometheus, but it is very specific to logs. We have Jaeger, which is in the distributed tracing space. We have Fluentd, which is for unified logging. We have Thanos, which is a high availability setup for Prometheus. So if you have a lot of Prometheus instances running within your infrastructure, Thanos is something that can help you with that. We have Cortex as well, which does similar work to Thanos. When you have multiple Prometheus setups that are present. You have OpenTelemetry, which is an open standard for metrics, logs, and traces, especially when you are collecting it from different sources. And lastly, Grafana, which is a visualization tool. So all of these tools which is listed here, some of them have uh, visualization capabilities built in, but Grafana is a very popular standalone visualization tool that is used by a lot of companies and different projects. And it is personally my favorite in this entire list because I got introduced to observability very recently, not very recently, but maybe about a year ago. And I think the ease at which you can create things in Grafana, just plug and play, it makes it very easy to use, and that's why it's my favorite. I have a short demo where I talk about that as well. So before I get into the demo, I'll just go through the chat. I think Kelvin has asked a question where he asked where observability fails within the different stages of DevOps. So, DevOps, as you all know, there are a lot of processes involved within the entire DevOps as well. CI/CD is just one of them, and even within CI/CD, you will have a lot of other things as well. You might want to run some tests. You might want to validate a few things. You might want to run some rules, some checks, and then only probably deploy your application to Docker and then orchestrate and do XYZ number of things as well. So now, if you visualize, this is a pipeline where a lot of things are happening in steps, and you will obviously implement some form of observability at each of these points. So, when you talk about when observability falls. Okay, I read it as fails, but where observability falls within the scope of DevOps is at these particular places. So things can be, let's say, when you're talking about, let's say, building a particular, building your application and then deploying it to the Docker registry. And the next step is you are pulling that image from your Docker registry, creating a container, putting it into a pod, and then provisioning a cluster or provisioning a pod on a Kubernetes cluster. So if this is your process, you can have observability implemented at each of these places, and you can collect data which is important for you. For example, let's say the image size might be a very critical factor for you. So what happens is when you create a Docker image for your particular code, let's say it is 208 MB or 200 MB, and that might be a very large size for your particular use case, your industry, or your application that you have. So when you have observability in place, what can happen is that if there are a lot of team members working on something and suddenly someone just checked in a code which was probably PR approved, merged and stuff, and that suddenly led to a skip in size, increase in size from let's say 200 MB to 250 MB. So if you have observability implemented there, you will have, let's say, a dashboard where it immediately says that, hey, okay, which was for the past 10 builds the image size was 200, but the 11th build you suddenly have a 250 MB image. So now, because you have a number, or you have an alert, or you have a check in place, you know that something has gone wrong. If you are already aware, you can choose to ignore it. But if you are not aware, you can definitely go back and check, hey, what went wrong here? Why that 50 MB has increased? So that is one place where you can put this. So depending on what are the critical factors for you, you can decide where you want to have it in your entire life cycle. So another example quickly that I want to probably talk about is testing. So if you have a particular pass percentage for your test cases that code coverage is a popular term that is used. So yet, let's say if your code coverage is less than 90%, make sure that that the build doesn't complete, or the image is not pushed. So this is basically a check, and this is sort of monitoring in place, which is talking to your test server, which is probably running tests. It is getting a number from there, which could basically mean code coverage. And when you have that metric with you, you do an analysis. Let's say, hey, okay, if it's less than 90, make sure that the build doesn't proceed because the code coverage is not achieved. So that could be another space where uh, you could implement observability in your DevOps cycle. To the answer of fails, because I read it as fails. So most of these tools, come with a lot of fail-safe options, with a primary, secondary option as well. So usually, what is happening? Let's say when I speak about Prometheus, what it's doing is it is basically collecting metrics from a lot of places, and it is pushing it to, let's say, a Grafana or an Elastic DB, or wherever you are probably pushing that to. So what these tools allow you to do is that these might have retry mechanisms. So let's say if some matrix is collected but it has not reached somewhere, they have internally some mechanism to check that, okay, hey, I collected this, but this is not available here, so it will retry that. So you have retry mechanisms. You have primary, secondary as well. So instead, so if you're taking an if your primary fails, your secondary can just kick in and take it and just pass it on. So these are some very basic, primitive fail-safe options that can be added when it comes to observability. Yeah, not only in DevOps but in any other space, possible. So for the demo, I'll just stop sharing the screen and quickly, show you what I'm doing. Again, it's a very basic demo as well. And I think before I get into that, Nancy has a very good question, which is how can we add security to our observability? Few things I think of is always keep a check of Docker image vulnerability. Absolutely. So, there are a lot of, when you talk about image vulnerability, there are a lot of scanning tools available that help you scan your, images for vulnerabilities, which basically report the vulnerabilities to you. I think even before that, just taking a step above, bringing the idea of multi-tenancy, not because I've spoken about it earlier, but multi-tenancy is something that a lot of organizations do today to optimize resources. So you don't generally go ahead until and it's very specific needs. You don't go ahead and provision an EC2 instance to every customer that you have. You probably might have a lot of customers on the same EC2 instance, or maybe even your internal teams might be on the same EC2 instance. So for a very basic example, let's say you have Prometheus, which is, or let's say you have a Grafana dashboard, which is collecting data and representing it for you. And because these are on one particular, instance, what can happen is that if there is some visualization or some data which is important or relevant only to marketing team, your finance team can also see it. So that is a very big security concern. You might not want your marketing team to know that, hey, what our financial budgets are, or what things are happening, or your developers to know what is happening in other teams. So this is where security comes in, where you can put checks like that. Okay, people belonging to this namespace. Talking about Kubernetes, example. So people belonging to this namespace have access only to this observability namespace, so they get access only to this data. In within an organization, it might not be a very big use case. But then when you talk about, let's say, finance industries, or when you talk about healthcare industries, where you have multiple clients on a same infrastructure, which are using a same Prometheus instance, for example, it due to regulatory compliance, it is extremely important and sensitive that your one person or one client is not able to see what the other person sees. And it's not just about personal data or user data, it's even about the observability data as well. So, to do those checks, you can put namespaces, you can use simple RBAC policies, you can create custom rules to ensure that, okay, if you are coming from this team, you have access only to this dashboard. Any other dashboard you try to access, you will get access prohibited or forbidden or things like that. So I think that is a very important aspect when it comes to observability security as well. I mean, access to observability data from people, and the image scanning is obviously one thing that can be added, but I felt that that is very critical to take care of as well. So what I'll do quickly is I'll stop sharing the screen and I'll see how do I do this. Let me go to entire screen. Let me share this. You should be able to see something. I guess this is visible. A thumbs up or a yes or
Yeah, this is visible. Looks fine
okay.
to me at least. Or maybe if someone can
Yeah,
just put it in chat if they want to see it more zoomed out or zoomed in.
I
But this
think we
is
can just fix our screens to like, make that screen the main one and then it's like clear.
yep, better. Cool. So what I've done here is this is the application that I built. I am not a front-end developer, so this is the best I can do. Uh, Dish in an H1, dish in an input type text, and a button. And what you see here is a very basic to-do application. What it does is that it allows you to add items to this, and these items are basically stored in a local Redis instance that is running. So it can take an input. So let's say I want to buy milk. I want to buy a sim. Uh, you know, attend a meetup and things like that. And when I'm doing this, it is basically being registered, stored in the Redis instance that I have. In terms of applications, what I'm doing is it's basically a Flask application in Python, and it is a very simple, like I told few methods about the home where you see the UI, a get function which basically gets these items. And then we have a add and a delete method. What basically does is it allows you to add and delete an item. What we are doing here is that so this is the application. Now, talking about the tools that I'm using to add observability to it, the first one is Prometheus. What I've done here is that I'm not using a Prometheus standalone instance. Usually, what happens in typical use case is you will have a Prometheus instance running on your in your infrastructure, which basically would be collecting metrics from a different set of applications or different set of tools or modules that you have. What I am doing here is that Prometheus basically allows you to add custom metrics within your applications that help you generate metrics in a Prometheus format. So what Prometheus has done is it has created an industry-wide format which is adopted by all the popular monitoring and visualization tool. And these format is basically very easy to understand for any developer or any person in the tech space. So what I am doing here is that I am making use of the Prometheus client. So this is basically the official client that is provided by Prometheus, and it is available for different languages. You have it for Go, you have it for Java, and you have it for Python as well. What this allows you to do is that it allows you to add custom metrics within your application, and you decide the point where you want these metrics to be collected from. So when I spoke about the e-commerce application at the beginning of the deck, we I spoke about the various modules components from where the metrics needs to be collected. So for instance, very basic things that I've added here is the request time for listing, request time for adding and removing. And then I have added a count, which is basically how many items that I've added and how many items that I have removed. So this is where I've defined what are the custom metrics that I want to integrate within my application. And within the different methods, I have defined that particular the metric that I've given that will be collected for that particular method. So for example, for example, when I talk about add, I am defining that, okay, you also track the time at the beginning of the request, how much time it's taking to the end. And I've also included request add count. which basically would be a gauge which would be just increasing plus one of with every request. And same thing with delete. So every time you hit a delete button, this will have a remove. This metric will be recording the number of items that is removed. And lastly, what we are doing is we are using another module called dispatcher. And what this basically does is that all the metrics that is generated by your application has to be pushed to a particular endpoint as well. So what it will do then is that whenever you have any visualization tool or any other tool that you're using, what it will do is that it will make the metrics available at the endpoint that I define. And from that endpoint, any tool that I'm using will be able to scrape the metrics. So I have given the endpoint over here as / metrics. So let us just go and see what happens here. So let's say I add one more thing, speak. So I added this, and let me just go and see what is happening at the metrics and endpoint. So because we have configured custom metrics in Prometheus, I have configured it at metrics, and this is the default metrics that is generated by Prometheus. So if you see, there are a lot of Python garbage collector details which are present. You know how many items, objects it has collected. There are a lot of things around virtual memory of the process, things like you know whatever, I mean, related to processes, CPU seconds, and things like that. What you see after this is these are the custom requests that we have uh, added here. So what you see here is the request time that we have given. We have given the request list time, the time added, time removed, and also the add count and the remove count over here as well. So remove count, add count, and this is what is happening here. So what I'll do is I'll just uh, run it once more, and then we'll just see what the matrix are. So if I go here and we have these items, let me just remove one and let us say it has updated. So if you see in this session, I added 0 and I removed 1. Now, this is what my application is doing, and this is where my custom metrics are generated. What I'm doing after that is I am using a tool called FluentBit, which is again an open source tool. And why I'm using FluentBit here is that it helps an observability pipeline. So it is a very easy plug and play tool. It has a concept called data pipeline. I'll not be going very much into detail, but what it essentially allows you to do is it helps you collect metrics and logs from different sources, perform some analysis, and push it to different sources, different destinations. So it basically helps you collect. It's basically a plug and play tool. So you define the input. If you want any process or filtering to be done, you define the filters, and then you have an output where your data will be pushed to. So again, this can be run on a system, on a server as well. Or what it can be doing is that it can run on your Kubernetes cluster or a particular instance as well. So it has something called as the configuration file where you define these parameters. So if you see here, I have defined a lot of inputs. I have defined a couple of outputs here. So what you see here is the input. I'm taking CPU as well. I'm taking Kubernetes message. If I have a Kubernetes cluster running, system D metrics, which is basically metrics about the system on a Unix or on a Linux-based system, and then I have defined the Prometheus script, which basically is collecting the metrics from my endpoint. So if you see, this is my custom application IP address. This is the custom endpoint. The port, and this is the custom endpoint. So it is also taking input from here. And output, if you see, it is using Prometheus remote write, which basically is a feature to take data from Prometheus instance and push it to on a Grafana dashboard. So I'll quickly show that Grafana dashboard as well. And these are the details related to I have a host, match URI port, TLS, and other details. Uh, and then what you do is, because I'm running it on my system, what I have to do is it runs as a service here. So let us just start the service based on the configuration that we have given. So what this will basically do is the service will run in the background, and it will start collecting data based on the inputs that we have given. So it will be basically the system details, the custom metrics that we have created for our application. and it will be sending it to the endpoint that we have. So currently, if you see, we have request add count as 0. Let me just add something here, attend meeting, or let's say by a phone, and maybe close the talk fast as we are beyond time limit. So these are the items I added. If I refresh, you see the add count has increased to 3, which is the count that we have defined, and the remove count is 1 because we have not removed anything. What we do is we go to Grafana. So Grafana has, again, you can install it on your local system on a Kubernetes cluster, or you can use their online Grafana cloud, which is again a freemium service. So till a particular limit, you can use Grafana for free. You can have a lot of data sources. You can have a lot of dashboards as well. So what I've done is I've defined the data source over here. And the moment I do is all I have to do is I have to just go to connections and create a new connection. And within data source, I'll define that what my source is. So in this case is the localhost application that I have. And what it will do is it will give me an address that this is where your metrics need to be sent. So if you remember seeing the configuration file that we have, this is the address that I've given that, okay, it will scrape the metrics from here and it will push it to this particular host. And after this, whatever the data or metrics that is sent will come into Grafana at this address. And then Grafana is intelligent enough to take it for you and display the dashboard. So I have already created a dashboard over here. So this is a to-do dashboard. And what you see over here are a few metrics. So I have CPU load, I have free memory, I have request response time, and I have number of requests as well. So let me just put it to 5 minutes. And if you see, I have added 3 requests. So we just saw that 3 requests were added, and we probably removed one. So uh, depending on how your application is and everything within your infrastructure, it might take some time to update the details there as well. And let me just add one more thing, add item 1. So now we should have 4 items added, and let me remove 2 items. So I have removed 2 items. Let us just go and see if this is updated. So if you see, I have added total 4 items and we have removed 3. We removed 2 items right now, and one was already removed earlier. So let us go ahead to our Grafana instance and check whether it has updated or not. So let me just refresh it and see. So like I said, it might take some time to refresh based on how our Fluent Bit instance is actually uh, collecting the information. So when Fluent Bit actually takes it, we will be able to see that that particular metric will be pushed to the Grafana instance. So it has taken something. Let us just go back and see if it updates. So it has still not updated. So maybe I'll wait for some time to see once it updates. But I think you get a very generic idea of how it works. Let's say let me just add a new visualization, for example, just to show you how you can collect the data that you have. So the data source is what we created in the earlier step, where we define that, okay, you take the metrics from the metrics from your local to-do applications will be given to the Grafana endpoint. So let's say these are the metrics which are present here. So let's say I want to get some details about the node, and I want to know about something related to disk. Does it have something? Yeah. So there are a lot of disk related things, disk IO time, disk read time, bytes, etc. So let's say I want to know the write time. So I select this, and all I need to do is run query. The moment I do this, because this data is already coming in from Prometheus to my Grafana instance, I have this data and it has already plotted for me that, okay, hey, your node disk write times in seconds has increased, and this might change based on real-time update or whenever this metric is generated. So usually by default there is a 2 second or a 3 second or a 4 second time interval that is given where you refresh and the data is generated. So that is how easy it is to create a dashboard. All you have to do is choose a metric that you want, just apply it and it'll come in place. Obviously, there are a lot of complexities involved when you want to create queries, as Nancy rightly pointed out. because it's not just about taking the data that is coming in and just putting it into a dashboard. You might have a lot of different sources from where it is coming, and you might have to process it, analyze it, and then present the data. So you can create separate queries over here where you can have different rules and get the data, get the dashboard created accordingly. So I'll just discard it for now. And let me see if this has refreshed. Okay, so it has not yet refreshed. Let me probably see what is happening here. So it is probably correcting just the node metrics is what it is being uh, messed up or loaded with, and that's what it is just pushing. So if you see, these are the numbers that is increasing because these are the metrics being sent. But initially, these were the numbers that were sent from our application, and it's basically based on the time that we have given. I don't exactly have an answer why this is not happening, but all I know is that the metrics are scraped at this point, which is 8, and the remove count is 3. And all it has to do is, this has to collect that data, and we need to, it'll just represent it over here. And I have a very good line that I use for demos that, why you should attend a stand-up comedy show when you have a live demo, because there are going to be some mishaps happening within the demo where you can have a good laugh or have a quirky smile because something or the other has to go wrong when you have a live demo. So I think that is what has happened here. And let's probably take it with a smile and a pinch of salt. But then that's all, I had to share in terms of the demo. So I hope you got an idea of what has happened here. Uh, just a quick recap, just on the demo front, we use FluentBit, which basically helps me create to build a pipeline. In that pipeline, I defined inputs. Input for me was my Python application, which is generating metrics. The nodes are the node metrics, which is basically numbers or metrics coming in from my local system. And then these are being pushed to Grafana, which is the destination. So I have an input. I didn't do any processing in between just to make it, easy to understand. But you can have a lot of rules in between, and then you have a destination, you have an output where this entire data is dumped. Okay, it is still not here. Maybe if it updates, I'll probably take a screenshot and put it as a tweet once that happens. So I think that's pretty much what I had. I know I have short the time as well.
Yeah, yeah. Thank you so much, Atul. Demo was great. Like sometimes demo gods is not with you. This usually happens, I think. It's really wonderful demo. I mean, I should say this. And thank you so much for presenting this. I just want to ask someone in the audience if anyone has any question. I think a lot of people asked already a few questions.
Hello, I have one question. This is Tanmay.
Yeah, yeah, we can
Yes,
hear
Yeah,
you.
Tanvi.
yeah. It was a great demo, Atul. Thanks for the
Thank you.
opportunity. Okay, so I have one question related to the Fluent bit. So as of now, we are using New Relic. Okay, so I
Sure.
wanted to understand whether Fluent bit is also something which is an agent-based utility that we have to install in the respective virtual host or virtual machine or the containers. Wanted to understand that part a bit more.
Yes, so New Relic is basically as a plugin which is available for FluentBit as well. So FluentBit, what I showed here was a service which is running on my laptop. If you are, let's say, on a Kubernetes cluster, you can create it. You can give it a namespace and have a pod or have a replica set which it configures for itself, and uh, it will you will basically build the pipeline within FluentBit. So like I showed as inputs, you will define what the inputs that are required, and at the endpoint, which is your destination, you can use New Relic as an uh, destination as well. So
Mm-hmm.
FluentBit runs as an agent wherever you can or in whatever way you want to, whether it's a Kubernetes cluster or a standalone server. You can just install it and it'll basically keep running. And based on the configuration file that you provide, according to things like you can define what are the scrape intervals that you want to scrape a metric every 2 seconds, every 5 seconds, every 10 seconds. So things like that, you define the inputs, the outputs, the filters, the parsers, and based on that configuration file, uh, your Fluent bit will take data from whatever you have given in the configuration file, input, process it, and then throw it to the destination that you have given.
Okay. So it acts like a sidecar, you mean?
No, so it doesn't come as a sidecar when you are using it in Kubernetes. The only demo that I have done within Kubernetes was it was installed as a replica set, which was running, within a particular namespace, and all I remember doing was just providing the configuration file with the service names that is required from where I want the metrics, and FluentBit was able to go and collect the metrics. So, for example, let's say I use something like a cube ADM or cube data metrics for Prometheus. So when that is running, it is already putting out the metrics at a particular endpoint, and FluentBit was able to scrape those metrics based on the data that I provide in the configuration file.
Hmm. Okay. Thanks. Thanks for clearing that.
Thank you.
Yeah, that's amazing, Atul. Your talk actually made me remind of so many things. So basically, I think like when we talk about observability, there are so many different types. So I was also a part of team where I have to work around the infrastructure, which is pretty much like what you described today, like using Prometheus and Fluent and Grafana. And I think the other one is the data pipelines. That I was a part of that team as well, and that was something very tricky because usually there are so less tools for data pipelines, and that's something I'm exploring. And maybe we could have a discussion around that in another talk. But if anyone has an experience around that, I'm happy to discuss in the audience. But yeah, that is something which was very tricky because we didn't had the I had very less knowledge of the tools in that domain, and that was a bit tricky. But yeah, this is great. I mean, thank you so much, Atul. Does anyone has any other questions?
I mean, being a developer, like I have used Prometheus and Grafana to very limited extent, but then thank you, Atul. Like I learned a lot of things today. I maybe will, dig deeper into all of this because sometime down the line, I'm sure I'll be using these tools in my, projects and all. So thank you for taking out your time on the Sunday. Like you came back, you were
Yeah.
traveling, you came back, and thank you, Nancy, even like for joining, and you were stuck in traffic, you still made it. And thanks everyone for joining. I think, yeah.
Yeah, I also want to thank so many people who joined for the first time. I guess Sindrad and Tan Tanmay. These are the new faces. So thank you so much for joining on Sunday. Joining on Sunday is a big thing, I must say. And if you have any feedback regarding our meetups and workshop, one I could think is maybe shifting the dates. Like I believe that maybe we could do it on weekdays rather than on weekend. That's my feedback. But if anyone has any other feedback, let me know. Thank you so much, Atul, for giving your time. Loved it. Thank you so much, everyone.